Okay, this is Mrs. Williams, and we are going to work on finding domain restrictions and simplifying rational expressions. So for part A, finding the domain restrictions, since we have a fraction, one thing you always want to check, if you're asked for domain restrictions and you have a fraction, whether it's a function or just an expression like this one, you want to make sure that your denominator is never equal to 0. So that is going to place a restriction on our domain. So to find out what value would make our denominator 0, we take our denominator and set it equal to 0, and we solve it. We make a little algebra equation out of it. So for part A, we're going to take 6m because that's our denominator. We're going to set it equal to 0 and divide by 6 to get m by itself. And that brings up another good point. 0 in the numerator is okay. 0 in the numerator, doesn't matter what you have in the denominator. If you divide this, you're going to get 0. So 0 divided by anything is 0. And so what this is saying is that if m is 0, it's going to make 6m equal to 0. So think about it over here. If I plugged in 0, 6 times 0 is 0. That would make the denominator 0, which is not good. That's an undefined value. And so that means that we need to restrict it to say m cannot equal 0, because if it does, then my denominator is 0, and we can't have zeros in denominators or fractions. Okay, so that's your answer for part A, is just m cannot equal 0. For part B, simplify the expression. I want you to think back to nice fractions that didn't have variables, right? Let's take this example. Let's say we had 4/5 plus 3/5 plus 1/5. Okay. Hopefully you remember that to add fractions you have to have a common denominator. So here we do have a common denominator. And then to go ahead and add those together, we would add the numerators. We'd do 4 plus 3 plus 1, like this. And, add all that up, you'd get 8, but we would put it over 5. Okay? So look over here at this problem. This looks very similar to this version, right? Before I added the numerators together. And so what we actually want to do for part B to simplify this is actually go from here to here. We're going to break it apart. Because this version isn't useful to us when you're dealing with monomials. Because this is as simplified as it gets, there aren't any like terms to add together here. So what we're going to do is we're going to think of this as one fraction, this is another fraction, and this is another fraction. So basically you have 3 fractions all with a common denominator. So it would look like this, 6m to the 4th over 6m plus 3m squared over 6m minus 12m over 6m. Okay, and I'm just keeping the signs that were there in between. Okay, and then you're going to look at each of these as a monomial over a monomial. And for example, 6 over 6, we know any number over itself reduces down to 1. 6 goes into 6 one time, and 6 goes into 6 one time. And then in the previous video, we also talked about what would happen to m to the 4th over m to the, this is really a first. If there isn't an exponent there, it's really a 1. And because there are 4 m's in the numerator, so let's just write it out over here. I'll stick my other m over there since I'm running out. There's 4 in the numerator and only 1 in the denominator. Well, one of the m's in the top will cancel with 1 in the bottom, but you still have 3 remaining up top. So we could cross this m to the first out and change this exponent to a 3. So from this first fraction, we really just have m cubed. That's all that's left. You have 1 over 1, which is 1, and we usually don't write that. You just write the variable. Okay? So similar idea here. 3 and 6, you look for a common factor, which would be 3. 3 goes into 3 once, and 3 goes into 6 twice. And then you have 2 m's up top. Well, one of those is going to cancel with the one underneath, And so we can change our exponent to 1. So we're going to have m to the first left in the numerator, and then we're going to have a 2 left in the denominator. Okay? And then here, 6 goes into each of these. 6 goes into 12 twice. 6 goes into 6 once. And then the m's both cancel, so we get minus 2. And that is your final answer because you have 3 terms left, but none of them are like terms, and so you cannot combine them. Okay, now this one, the similar idea. For part A, we don't want our denominator to equal 0. So we're going to take our denominator and we're going to say, okay, we're going to come over here and we're going to set our denominator equal to 0. We want to find out where would it equal 0, and we're going to restrict it from that. That would be what it cannot equal. Okay? Okay, so remember, to solve this, what you have to do is factor it. Okay? You have, do like a backwards FOIL here. We're going to have s and s. That would multiply to give us this s squared right here. And then 8. What factors of 8 would multiply to negative 8 and add to negative 2? Okay, so you could even do a little T-chart over here. We want to see which numbers would multiply to negative 8 but add up to negative 2. So we have negative 4 times positive 2. You could have positive 4 times negative 2. You could have 1 times negative 8. You could have negative 1 times positive 8. All of those combinations would multiply to negative 8. Let's see which of those would add to negative 2. Negative 4 plus 2, that would work. Okay, so we got lucky, our very first one. But you could keep going if you needed to. Just follow the idea down. 4 plus negative 2, close, that would give us positive 2, but we're looking for negative 2. So it's this first combination, negative 4, positive 2. So you just put those numbers in. Negative 4, positive 2 equals 0. Okay? What this is saying, look at, these parentheses mean multiplication. You're taking s minus 4 times s plus 2. So remember, if you multiply by 0, you're going to get 0. So that means if s minus 4 is 0, this would, this whole expression here would turn to 0, and you'd be multiplying it by s plus 2, which would make it 0. Or if s plus 2 turned out to be 0, and you multiplied it by s minus 4, it's going to be 0. 0 times anything is 0. So from here, what you do is you actually want to make 2 mini equations, because if either one of these is, if s minus 4 is 0, or if s plus 2 is 0, that will make the overall left side there 0. Okay? And so we have 2 little mini algebra equations. We're going to take each of those here. We would just add 4 to each side and get s equals 4. And here we're just going to subtract 2 from each side. S equals negative 2. Okay? So these are the 2 values that would make the denominator 0. So those are the 2 things that we want to restrict. We don't want those 2 numbers in our domain because it would make our denominator 0. And you can check it out and try it. If you plug 4 in here, we're going to get 4 squared, which is 16, minus 2 times 4. 2 times 4 is 8, so we'd have 16 minus 8, which is 8. 8 minus 8, yep, that gives us 0. Okay, so that's bad. Okay, so we're going to say our domain restrictions are that s cannot equal 4 and s cannot equal 2. Okay? All right, for part B, simplifying the expression, it's a little bit different than the problem we did previously. The problem that we just did, you just had you had a monomial down here. You didn't have any, it was just one term. Here you have 3 terms. So if you come across that type of situation, most likely what you're going to do is you're going to factor. And we've actually done that in part A already. So let me make my division symbol here. We're going to have s minus 4 and s plus 2 is what the denominator factored into. Now we're going to do a similar thing in the numerator. So we're going to have two sets of parentheses. We're going to have S and we're going to have S. And again, we're looking for that combination. I'll do it over here. Where it adds to your, or I mean, excuse me, multiplies to your last term and adds to your middle term. So we want two numbers that multiply to positive 4 and that add to positive 4. This one's not too hard, right? 2 times 2 multiplies to 4, and 2 plus 2 adds to 4. So we're going to put positive 2's in here. Okay. Now, this is sometimes hard to see when you first start doing this, but once you get used to it, you'll see, you know, that this happens quite a bit. If you look at what's in this parenthesis and what's in this parenthesis, they're the same, right? This is the same idea as, you know, if you had 5 over 5, that reduces down to 1, right? So same thing here, these cancel out, and then all you have left is S plus 2 over S minus 4, and that's your answer for part B.